Okay, so this little station here is going to introduce you on how to do the line voltage wiring, the stuff that we do in the field after we hook up the unit. Now, not only are you going to do the stuff that we do in the field, which is normally the power from the disconnect to the condensing unit control panel. Now, I've got this all split apart for you, okay, so that we can see the components. It's a little different than what you would actually see, follow me over here real quick, in our straight cool unit. But you can see that the stuff pretty much matches. I mean, we got a fan motor on the top. You know that down in there somewhere in the center, what component's going to be in the center of that unit? The compressor, you got it, yep. And the compressor needs two things to start. It needs a capacitor in the start circuit, and it needs a contactor to open and close when the thermostat calls for it. So this is the same thing. And you're going to use the wiring diagram that's on the inside of the unit. And there's two types. There's a pictorial that shows component arrangement and how the colors of the wires and where they go. And then there's a ladder schematic. The ladder schematic is more for troubleshooting. So if we run into trouble with this piece of equipment or any other one, this is the one I'm going to refer back to for like a road map to see how the electricity is traveling. But for connection purposes, the pictorial is the one that we're going to use. And if you take a look, I got it upside down. It shows you the control box right here. It shows you that you got a fan motor, CM, that's condenser motor if you look at the legend off to the side. COMP, there's my compressor. And there's my three terminals, common, start, run. My capacitors here with the terminals identified, HERM, F, C. That matches the capacitor up here. There's terminals matched there for HERM, F for the fan, and C for the compressor. And then there's also a contactor here. There could be, where you see the dotted lines, additional accessories like an additional hard start cap. That's not on here. I only have one cap, all right, not the extra hard start. And then there's a relay that goes with that extra hard start cap. So I don't have the relay or the extra hard start. We just have the contactor and the capacitor, okay? And on that contactor, they show you T1, T2, that goes to my load, and L1, L2 comes from my line, okay? My line being the voltage wire from the disconnect here. So we're going to leave all this here like this. You also will need the fan motor here. We got the fan motor that I'm going to connect up there. And off to the side, we have the compressor for this unit. Now these compressors, it used to be that you had to find, like what we did at the beginning with the refrigeration compressors, common, start, run. But Copeland and a few of the other manufacturers have been making it idiot proof. In other words, this plug cannot go on any other way other than the way it's supposed to for common, start, run. So you don't even need to worry about finding common, start, run because they've already identified it for you there with the three wires. You just need to make sure that if this one says run is red, I don't have a red here. You're going to have to find out that run is actually my yellow wire, my yellow lead, okay? So that's going to be a little different from maybe this diagram because it's not an exact match for this compressor here, but it's pretty close, okay? So that's all the components. You got your fan motor, outdoor fan motor. That has three wires. Again, two are power, one is for the cap. Because that motor north-south is locked up. We need to kind of jolt the phase to get the motor to rotate that first time. Same thing with this one here. Got three wires. Two are going to be my run and my common, and one's going to be just for starting. So when you get up here to the contactor, this is a typical 30 amp non-fused blade type disconnect. There are some that have fuses in them, and then the two primary ones we use in HVAC are either 30 amp or 60 amp. Actually, this one here says it can handle up to 60 amps, but this is a non-fuse. So you're also going to need, I would get the Klein screwdriver. The 11-in-1 works good because it has all the stuff that you need for this project. All right, pull the cover back. This is just for ease, so that when I'm working, I don't get it doesn't fall in my hand, it doesn't cut up my hand. So you got to be careful though. It only comes off a certain way. Usually you put it up in there like that, and then that's in, and it won't just pull off. You got to have to kind of find how it slides off around the hook on the dimple, okay? The blade type non-fuse, it just pulls out. And you can see right here, this got burned up a little bit because when somebody plugged it in, they forgot to check the ground to see if something was shorted. So when they went to jack it in like that, this one here it sparked up a little bit, and it got so hot that it actually melted one of the blades inside there. So I would normally not give you this one to use. This one's just for practice, and I don't care if this one gets damaged anymore. If you take a look on the lugs, I got one that just goes to the box. These are my grounding lugs. This is going to connect up my ground wire. I also have 2 over here and 2 over here. One of these is going to be for my line. One of these is going to be for load. If you can't see it because it's too dark, you might need to crack out. Let me see somebody's phone with the flashlight on real quick, because you might need it. I'm using mine for recording video. There we go. You might need it to get up in there to see. Oh, look, I can see it now. Lines off here onto the left, loads over here on the right. So my load one is going to go to my unit. The line one would go from my line voltage back to the breaker. Thank you very much. I'm going to go ahead and we're going to start with line. In this case here, normally you would have this already run. Electrician really has to run this. You got to be licensed to run from the disconnect to the panel. Although I do see a lot of HVAC guys doing it themselves. That's okay. So, but we're going to go ahead and we're going to put these on. And look, they've knocked out the knockouts in this one more than what my connector is. In fact, if I tried to just put this on here like that, it really wouldn't work because it falls through. And then when I put the lock nut on, like this, all right, it won't lock around anything because there's nothing to lock onto. Oh, we got all kinds of trash in here. I gotta cut that back a little bit. But we can put that in there like that, and then without the collar, when I go to lock it in, it really doesn't give it a good enough grip. As you can see, nothing. So you're gonna have to use these rings, okay, or KO rings, knockout rings, because what happened here is this got knocked out. They're flimsy and they're multiple sizes. So that one there's for 1/2 inch, 3/4, 1 inch, and that's what we have now, the 1 inch exposed, and we need the 3/4 inch. So you're going to need to sandwich 2 of these rings around the pipe. And really, we're not supposed to have more than 1/2 inch of this stuff sticking out, this outer insulation. Somebody didn't cut enough. If somebody wants to go get me a pair of dikes, I can trim that up real quick. We're going to go ahead and put this in. You can see how it keeps getting in the way of everything. And then I got to put the other ring on. You can see what kind of a pain this stuff is getting into here. Not letting it go. Let me see those dikes. We're going to trim this up first. This is the reason why we trim up the sheathing. They're not supposed to have a 1/2 inch of sheathing beyond the connector. We obviously have 1 inch. So I'm going to go ahead. We're going to trim the sheathing off a little bit. All right, because the kid didn't do it the last time. And you can see the signatures here. Those are all the kids that have completed this project. When you complete the project, you need to add your signature to that list. All right, some of those kids are off making really good money right now. Maybe even some more than me. Alright, so look, we're going to slide that in. You're going to see it's going to have a little easier time now. For the ring first, alright, put the ring in first. And then we can put the lock nut on. And now with the 2 rings keeping that in place, we'll be able to have it hold. Alright, so I'm going to go ahead. We're going to take it and screw it on by hand first. Alright, remember, keep the screws where we can get to them if you need to. You don't want to put it opposite. And then I'm going to go ahead and we're just going to lock it in place by taking the screwdriver and tapping it up. Alright, tap it up and that locks it in. Now we're locked in. That's good. So that's done. If the connections are too old, okay, because I have this size for some pretty big wire here for big load, a lot bigger than what it needs. But you might need to, if you need to, cut a little bit off and strip it. I'm going to go ahead and reuse these one more time. Alright, so I'm going to go ahead and twist them up so the solids, so all the strands become like one solid. Alright, I'm going to actually clean this one up a little bit. And then we're going to go in and I'm going to do the ground first. So I'm going to actually put this one on this side. Let me back this out with my hand first. We'll slide this up under the ground lug and we'll tighten up the ground and we're done with our ground from the line. I will also show you how to mount this disconnect box another time, because some of you might need to mount a disconnect box. You might already have one there for you, or you might need me to mount one for you. Now look, these other lugs, they fall out if you loosen them up too much. So if I take, you don't want to loosen them up all the way where these screws fall out. And if you lose this lug here, if it drops out, you might have a hard time. You got to get it up underneath this part of the blade. See that there, that locks in? That's what's got to go up underneath, because that, between the wire and that part of the blade, and it doesn't matter, I can put black here, black there, it doesn't matter, but I'm going to go ahead, I'm going to shove this up in there so it's got the blade and the wire, but no insulation, goes up underneath the screw terminal. And then I can take it, hold it in there like that. You got to kind of do two things at once. And when I tighten up the lug on that terminal, it'll lock into both the blade, all right, and then now we got copper wire and aluminum terminals. Anybody know what happens when I mix two metals together? Got this thing called electrolysis. Electrolysis is where the atoms from one metal kind of corrode against another metal. It generates a little bit of electricity, and it forms what's called the creep on this wire. It actually heats up the wire and it burns away the insulation. So if you're using an aluminum terminal block with copper wire, there's this stuff called no-locks that we're supposed to put on this wire. Now, we're not going to put it on this one for you guys because it gets messy. It's a paste, but I will show you that another time. So what you would do is you would take this wire and you would just dip it in the no-locks. It's a paste for electrical work, and then you wouldn't get that electrolysis happening. We wouldn't have the two dissimilar metals creating a different, creating the creep on that wire. So, but we're just going to go ahead because it's messy. I'm not going to use that with you right now. And then I can go ahead and set the other line up on the other side.
You could switch them to like that.
Doesn't matter. Yeah, because we got 240 volts here. As long as I got 120 here, 120, or I can switch it and do white and black there. The phase doesn't matter for that because they're both the same. Now that's it. And just give it a little pull. I pulled on the insulation, made sure that, okay, as long as the wire doesn't pull down, we're good. You notice it shakes a little bit. That's okay. That's the whole thing shaking, as long as the terminal's locked in there with that screw. Now for this next part. Again, normally you'd have a couple more pieces, but this is all just practice. And normally you would run this Armaflex liquid tight from the disconnect to the panel, okay? And you probably have to run it and lock it in up here. Now we're just gonna make, this is again just to practice, show you the wiring for the connection. So we're not gonna do this all the way yet. This is more just practice. So if I'm gonna go ahead and take this wire and we're gonna run it through. Actually, I'm gonna try and knock one of these out. I'm gonna try and do this straight one here, and I'm gonna just show you what could happen. So let's say you had to knock this knockout here. Let's say it was a brand new disconnect box. If you look, it's connected on one side, but the rest of it's stamped metal. It's kind of stamped out, and then I got two connections down here. What you wanna do is you wanna take the screwdriver to the part you wanna knock out and gently give it a little tap on either side. Eventually it should break free. Now, the danger is that I might hit so hard that it breaks one of the outer rings. If that happens, I gotta kind of do something a little different. But if it doesn't, and I just get the one I want, like that one there, and normally I'd use a different screwdriver than the multi one. This one's not the best one to hit with a hammer. But you can see what's gonna happen. I'm gonna just tap gently back and forth, and what's gonna happen is the teeth are gonna break off eventually. So I just keep wiggling it. Takes a little time. Oh, look at that there. See that? And I'm not hitting hard enough to where any of the others knocked out. Now, if it's still not the right size, like this one here, it doesn't look like 1/2 inch. Oh, maybe. I don't know. It's not, I don't know. We'll go ahead, we'll shove the wires through. Let's see if we got the right one. Ah, darn it, it's the bigger one. I could have told you that, really. But I just wanted to show you that it's not the right one. So now I got to carefully remove the second ring without losing this one. If I lose this ring, then I'm going to need some more of these to make it work. But we're going to go ahead, and for this part here, This one breaks on the outer edge. You can see I've already broken it a little bit there. I'm gonna just bend it back a little bit with my dikes. Sometimes you can also cut it, all right, and then wiggle it this way. So now I've got both of them, and I can just wiggle it out gently, making sure not to break the outer ring, because once that breaks, this is done. All right, that one's done. I got that piece out, and now we can get this one out. Again, just wiggle it a little bit, and it'll come. Calm down. Calm down. All right, there we go. Now let's try it again. And this one, because I did the right size, I should not need the ring. I just need the lock nut. So again, we just shove them all in. Anybody remember how much wire you're supposed to have sticking out?
Like that.
Like that, 6 inches, yep, that much wire. All right, you don't need no more, no less. So I'm gonna go ahead, we'll put that in there like that. Somebody hold this up over here. All right, while I get that, make it easy for me. And then, yeah, we got way more than I need, so I'm gonna pull some back. All right, we can probably pull back the red and the green, just the red now a little bit. All right, and that's it. That's about as much as we need coming out. And look, I don't have to, I can get all three at the same time. Put the lock nut on and lock it in place. See how the bevel's going in? I want these to go out and lock in on the teeth. So I gotta flip it around, because you see there is a difference between the front and the back. Some don't. Some look exactly the same front to back, so it really doesn't matter. That one's got a little bevel on the outside edge. So we lock this in. Give it a little tap. That's it. That's good. Okay. So now we're going to go ahead and we're going to put the ground in first. And this is solid wire, so I'm going to kind of use it to keep the stranded stuff pushed back. I'll use the solid as like a right there. We'll just push it back a little bit. Now, normally I would also have rings that cover this stuff up. We can't leave any openings in the unit. So if this was on the unit on the side of your house, I would cover that up with these special KO knockout covers is what they're called. And they're just for if you knock something out and you want to later on change your mind. All right, that's it for that one. And again, normally we'd have the no locks, but again, it would make it very messy for you. The next person that came up would get the gray stuff all over their hand. I am gonna go ahead and redo these. Strippers would be better, but we're gonna go ahead and use it. As long as none of the little strands break off, are we doing okay? All right. Now, what determines what size wire we're gonna use on this unit here? Anybody know? How do I know what size wire? Because this one obviously looks thicker than this one.
The AUG.
The AUG, yeah. Why would I need bigger AUG? What would we require in bigger AUG over there? Why would you need bigger AUG? What's the wire size for? Volts, amps, or ohms? Amps, that's right. And if we get too much current, too much amps running through the wire, if it's too small of a wire, we have too high of a load down there, it'll burn the wire up. So you really don't need to worry about going too big. Too big's okay, all right? You can get bigger's better, but too small would cause a problem. So now that's it. That's done. The disconnect's done. Once you get that disconnect done, let me come over, look at it, and then you put that back in there like that, and then we can put the cover back on, and we can come back over for the second part. That's part one, okay? Part one, and you don't plug it in yet. We're not gonna plug anything in to the very end. So part two now, you're going to take these wires, and this is what you're going to have to do on your unit. You're going to have to wire them up. Normally you would, again, have another lock nut and come in, but we never would just run the wire, and I'm actually going to trim some of this back, through without a connector. You'd always have a connector. Because what would happen is as the unit vibrates, it would rub along the outer insulation and then eventually cut through the wire and create a short circuit. So you would have another lock nut, connector, and you would run it through here and tap it down. But for the purpose of, you're not going to be running it that long, and there's nothing vibrating here because the parts are separated. We're just going to be, this is practicing the procedure for the wiring, okay? Just let me see you do it on this first before you do it on your unit. It's good to practice on this stuff here. So I'm going to go ahead and strip all my stuff back, get it ready. Where's my ground look like? Where's my ground at? Yeah, but where's it go here on this unit? Anybody know? Yeah, you can see the 3 lines, all right, that go downward as a triangle right there. And then, yep, that's my grounding lug. Look just like the lug over in the disconnect. So that's where we're going to connect the ground to first. And then again, it doesn't matter on this contactor, all right, what side goes where. Red, black, black, red, doesn't matter, okay? It can be either one. But I generally, whatever goes with red, I'm going to keep the red side. Whatever goes with black, I'm going to keep the black side. So, again, I'm going to go ahead, I'm going to do the ground first. You're going to put the ground just through the hole here for now. And then put it in the lug nut. There's my little screwdriver over there. Lock it in. That's fine. Alright, now that ground's locked in, and we're going to go ahead and we're going to take the other power lead. Remember, each one of these has got 120 volts going to it. Alright, you do not want to shove it up to where it could get underneath the points of the contacts. Alright, just back it a little bit, and no insulation up underneath the lug. You might have to switch sides over here. Switch back. Alright, so there's L1, and now we're going to do L2. And it should match, like, look, L1, L2. L2 arrow's pointing here, L1's there, T1, T2. It's telling you on this contactor, which should line up with the wiring diagram that we have here on our little Goodman unit. Okay, so again, we got that locked in. Now for this next part, that's it. Load voltage wired up. Now we're ready to do our loads, our independent loads. So if I go, and I'll pick a component, the fan motor. Look, there's another wiring diagram here. It says black and purple are my line. Cap goes to brown. So I know that's going to go up there. Probably on the one that says Herm, F or C. What's the fan motor start with? What letter?
F.
F. So probably going to be F here. Yep. And if I take a look on my cap, I find my cap and I look at F, and oh look, that's a brown wire that goes back to my auxiliary coil of the fan motor, the start winding on the fan motor. So I could do that one first because that's easy to find. So I go up here and I find that, oh, it's fan. They gave me the whole letter, whole word, fan, F-A-N. That's it. That one's done. Now I'm going to go ahead. We could, again, it doesn't matter. I could put purple here with the black, or let's just go ahead and match the colors. Because one for the fan is going to go back to T1, and then the other one is going to go to T2. So it really doesn't matter. But I'm going to go ahead and I'm going to match the colors. So there's T1 for purple, T2, and that's it. The fan motor's done. Now, got my other load, the compressor. And again, I already know that my yellow would be normally red. Oh, look, there's red there. So we can go ahead and we can... Where'd my little screwdriver go? I dropped that bad boy over here. All right, so I'm going to put... I got to loosen up these lugs here. And, look at that. Now, it would be great if that was red and that this was red and it matched up with my red down there, but it doesn't. All right? It doesn't, but that's okay. As long as I follow the wiring diagram and know where it goes. And I'm going to go ahead and put the black one where the blacks are, so at least all the blacks line up. And if you look, the start one, it doesn't have the same forked spade terminal that this one does, right? And so I know that that one's going to go up here. I know that that one's going to go up to the top. And that's locked in. So now I just have 2 more connections. I've got, this is the Herm, hermetic compressor. So I'm gonna put this one on the Herm. And then look. Oh man, I got one more terminal block. C. It's gotta go somewhere. Probably has to go on one of these leads for this contactor. So if you follow this compressor back, this Herm, right? All right, so the Herm's got more than one yellow, that's fine. The fan, and then there's, my C. Oh look, they can put the red one to that. A red one goes to T2, and the purple one from the fan. So I could put the purple to the fan here, or I could put it on this common up here. It's gonna be the same thing, because what I'm gonna do is I'm gonna jump this to T2. So this is gonna go from common to T2. And that's it, it's wired up. Now, I can move this one here and put it there. It's the same thing because of this jumper. Doesn't matter where I get it. Only thing is, this is now gonna power up this and whatever else we got for the start circuit, whereas the load for the wire now is just determined by these two for this load wire.